Okay, finishing our last 7.2 video, which did graphing logarithms. Now it's going to throw in a little bit at the end there of properties of logarithms, where you have to change a log to an exponent to a log. I wish I would have kind of hit that first in the beginning of the lesson. I'll probably do that next year just to make it better. We got Jace and crew here finishing their work. Name drop. Woo! During lunch. The dedication. Okay, so let's see here. So let's talk about more how to rewrite a logarithm as an exponential. So basically what you do, so here's the example they give you. So log base 5 of 25 is 2. And they want you to rewrite that as an exponential because they're opposites of each other, right? Exponential and logs are opposites of each other. And so basically, you would take the 5, you always start with the base. And so you take the 5 and you put it to the second power, which equals that number right there. So that would be 5 squared is 25, which is true. 5 squared is 25. And so I'll show you both statements on our calculator here. So basically, here's both statements. So 5 squared is 25. And then, so what the logarithm is doing is trying to find that missing power. So if I went math button, and I did log base 5 of 25, then what the logarithm finds is the missing exponent. So 5 to what power is 25? And when you push enter, it says, oh, 5 squared is 25. So the missing exponent is 2, because 5 squared is 25. So we can also go the other way. So here it says 2 to the third power is 8. And so let's say that I didn't know what that 3 existed. And so, or we'll just show you how to rewrite it. So but this time we're going to, instead of doing e, so 2 to the 8th power is 3. So now we're going to do a log. So we go L to the second power, log base 2, of 3 is 8, which is true. And so now we need to change, so we're going to change it to a log. So basically we go log of base 2 of 8 equals 3. So log base 2 of 8 equals 3. And so that is our answer. And so we can kind of show you how that works again in the calculator. So 2 to the 8th power, 2 to the third power is 8. And then also, it's also true that log base 2 of the solution 8 equals the exponent 3. So I'm going to write this better with kind of a formula that hopefully it covers on the notes. I'm not sure. But I'm going to do it right now. Let's see. So basically it's this idea that you have your base to the exponent equals your solution, right? Like 2 to the second power is 4. The solution's 4. So now we're going to rewrite it as a logarithm. And so how the logarithm works is you have logarithm of the base of the solution, right? And so what that equals is the exponent. It's the exponent. So I'd probably write that in your notes somewhere. Yeah, so log base of the solution equals the exponent. So hopefully that makes more sense when we're doing these. So hopefully that makes more sense. Use your calculator to evaluate the logarithm. Round your answer to 3 decimal places. Use change of base formula if you have a TI-83. So basically, if you, so there's 2 ways to do these. There's actually more than that, but there's 2 ways to do these. So one way is to just set it equal to x and solve for x. And so I would be 1/8 to the x power equals 64. And you could guess and check. Well, I know squared is 64. So x is probably a -2 is what I'm going to guess. Is 1/8 to the -2, does that equal 64 because you flip and change it? I think so. Another way is to plug it into your calculator. So you go math button, you go down to option A, log base of 1/8 of 64. What's the missing exponent? Look, it found it for you. It's -2. And then the last way, so that's just plugging it straight into your calculator and getting -2. And then the last way to do it, if you have a TI-83 or your 84 doesn't have that special log base, is to do the change of base feature. And so the change of base basically goes like this. So the change of base is you draw a line down the middle, and then you use the log on the top and the bottom. So use base 10 is what you're actually using. So just the log button, right, is actually base 10. And I'm going to prove it to you. So log of 100, if this is in fact a base 10, which it is, would be, what gets to 100? How does 10 get to 100? What exponent? So 10 squared. So there it is. 10 squared is 100. So the log button uses base 10 when you hit that log button. And so change of base uses the base 10. So what you're actually going to do now is you're going to do log base 10 of 64 divided by, parentheses, log base 10, it's a visible 10 there, of 1/8. And so there it is. The answer is -2 still. So what we did is we turned this into using the change of base feature. So we went ahead and made this log base 10 of the top number, the solution, divided by log base 10 of 1/8. And so that still gives you -2. So both ways work, right? You can use the math button, go to option A, log base, or you can do the change of base. So give that a try, So I'm going to try using change of base on this one, but I'm also going to try the -2 in front and see if it works. So -2 is on the outside, and then we do log of 0.015 divided by log 3. And so I'm going to see if that works and see if it matches with the log base feature as well. Okay, here we go. So -2 parenthesis, log base 10 of 0.015. Let me see here. Yep, divided by log 3. So that's log 3. And so the answer we get is 7.645. Now I'm going to go math button and try the log base feature. But I'm going to shove a -2 in the front. So second insert a -2 in the front. Or you could do -2 first and then do math log base. And then we have a base of 3 and the 0.015. And we got the same answer. We did it right. So 7.645. So 7.645. It says 3 decimal places. And so that's going to be 6454. So we're okay that that's going to truncate off. And that's our answer. And this is our answer for that one. So try 27, try number 30. Give those a try. And then last but not least, multiple choice. So this time they're saying your P of 0 is your initial population, which is 782,000. And then 1 plus the rate, and the rate they want us to use is 5% per year. So that's going to be 0.05. And they want you to do it for 1990 to 2000. So that's 10 years. That's why there's a 10 on the outside, because it's 10 years. But they also want you to compound it. And what do they want you to compound it with? Let me see. Constant rates. So grows at a constant rate per year. There's your formula after T years, initial population, student population is at a constant rate of 5%. So I guess because they give us the constant rates, yeah, we can go ahead and not have to worry about the compounding at all. So just once per year is where we're going to compound that, so that's fine. And so what is 1 plus 0.05? So 1 plus 0.05 is just 1.05, which is going to be our answer. And so it's going to be 782,000 is our initial population, 1.05 rate, to the 10th power. And so I'm just going to double check. Yep, that's what the other teachers got too. All right, thanks for watching. See you next time on 7.3 where it gets a little easier. Thanks for watching and bye for now. Bye for now. Thanks for watching. Wayo.